Okay, so you talked about not understanding light energy as part of what you have been taught in basic science. So I've excuse me, I've gone through the notes you sent, and I've brought out about 6 items we are going to quickly discuss about. The first item is definition. Okay? In other words, you are expected to know the definition of what light is, okay, how to define light, okay. So that's where we'll start from. So light energy. We are talking about the definition now. You are expected to know how to define light energy. In fact, let me just go to your notes where it was defined. From this your note now, you would see that your note says that light energy is the energy which enables us to see. Okay? It can be made to do work by the use of device called photoelectric cell. So you have to know this definition. I know it is easy for you to understand this first part, which says that light is the energy which enables us to see. That one is clear, right? This second part where they said it can be made to do work by the use of device called photoelectric cell. Let me quickly explain what that part is saying. If you look at the solar panel on the roof, it has wires that are connected to that box that is inside the panel, right? The light from the sun hits the solar panel, okay? When the light from the sun hits the solar panel, it converts the light energy. The solar panel converts the light energy into electrons, okay? And it is these electrons that is used in charging that box. In other words, the solar panel generates electricity by using the energy from the sun, okay? So that solar panel is also referred to as a photoelectric cell. Do you understand now? So it has been made to do work. Which work are we talking about? The work of charging that box. Okay? I hope that is clear now. So we are done with the definition. I'm going back to our table of contents. So we are done with the definition, which is number 1. Number 2, let's talk about the properties of light. So we are done with definition. Now we are talking about properties of light. Okay, let me go to your notes where you learned about properties of light so that we can explain any part that appears to be confusing. So properties of light. Okay, the first one here talks about properties of light. Okay, it's still under here. Good. So now we are talking about the properties of light now. Properties of light energy. The first one says that it travels not on, it is in. This is I, it's not O. Okay, this is letter I. Excuse me. This is letter I, not O. It travels in a straight line. What they are trying to say is this: light travels in straight lines. Okay, you cannot see light traveling and bending like this, except maybe it has hit an object or an obstacle. Do you understand? So light travel in straight lines. Light don't bend around. Do you understand? I hope that first one is easy to understand. The second one says that it enables scent back when falling on objects. From my observation, it's like you were being dictated to. It's like you were writing these things by dictation and not from the board. But what the second one is saying is this: the second one is trying to say that it could be sent back, not it enable sent back. It's not making any sense. It could be sent back when falling on an object. Let me go and explain this here. So we are still talking about properties of light. The first one we said, one, light travels in a straight line, and we've explained that, right? I believe that one is clear now. Number two, it could be sent back when it falls on an object. This is what it means. If this is a mirror here, this part I'm putting all these shadings now, they are the back of the mirror, okay? This is where you look at, okay? Now if there is a mirror here, when you look at the mirror, that's light falling on the mirror, it sends it back to you. That's how you see your reflection. Do you understand? In other words, light could be reflected. When it hits an object, it could be bounced back. So you don't need to cram what you have written in that place, in that part of your note, because it's like you made a mistake. Maybe you didn't see what is on the board properly. But what we are just saying here is that light can be sent back when it hits an object. That's another property of light. Okay? That's reflection now. Okay? Reflection. Excuse me, let me. Trying to clean this. Just hold on a second. Okay, so what we are saying now is that we have gotten reflection as one property of light, right? Then the number 3 property of light is refraction. Is what? Refraction. Take notes. Reflection and refraction, they are different. Okay? In reflection, like we just explained, when the light hits an object, it does not pass through the object. It goes back to the same area where it is coming from. Okay? Whereas in refraction, when light passes through one medium, example air. Okay? Let's assume that this is air now. Okay? This is air and this is water. Okay? So you can see that this air is one medium, water is another medium. Okay, when light passes from one medium like air to water, for instance, there is a bending. The light does not continue in a straight line, rather it bends. Okay, this straight line I've just drawn here now between the two medium is what we refer to as normal. Is what we refer to as what? Normal. Normal is any line that is drawn perpendicular to a particular surface. When we say perpendicular, it simply means that the angle here is 90 degrees. Do you understand? So in refraction, when light hits a medium, it is bent. Do you understand? So when they ask you to itemize the properties of light now, you can state these 3 properties. Number 1, light travels in straight lines. Number 2, it could be bounced back when it falls on an object. That is talking about reflection. We can talk about reflection. Then number 3, it can pass from one medium to another. You have just talked about refraction. So is there anything about properties of light that you don't understand now? So I want to believe that we are done with properties of light. Okay. Let's check our table of contents again. We've talked about definition, we've talked about properties of light. Now let's talk about terms related to light, which is number 3. Terms related to light. Terms related to light. Terms related to light. Okay? When we are talking about terms related to light, don't think about it too much. It's not as deep as you are thinking about it. Terms related to light simply means what are those jargons, what are those things that we can use in describing light. The first one that you should know is light ray. Light ray. What is light ray? Light ray simply means the direction through which light passes. Okay, it's just a single arrow like this that you can use in representing light ray. But let's check your notes and see exactly how it is described, just for exam purpose. So if you check your notes here now, you would see that here is it again. Is it laws of reflection? No. terms related to light. You can see that everything I'm treating is part of your note, right? Number one, they say talks about ray of light, or call it light ray. They say this is the part. This your spelling of part is not correct. That is why I'm beginning to think that you did not copy from the board. This is the part. The part you're talking about is P-A-T-H. P-A-T-H is different from P-A-R-T, okay? Part, that's the direction being taken by the, obviously I know the next thing you will want to write is light. The direction being taken by the light, okay? Direction being taken by the lights. That is that's light ray now, okay? Then the next thing, the next property, okay, I've heard the light, the direction being taken by the light, or the path being taken by the light, that's light ray. So the next term related to light, as has been treated in your note, is beam of light, or you call it light beam. Whether you call it light beam or beam of light is the same thing. What is light beam? Light beam is just a collection of more than one light ray. Okay? A collection of more than one light ray is what's called light beam, or a beam of light. Do you understand? So I believe you now understand light ray, you now understand light beam. Now, even in this light beam, it is good you know about the different types of beams that we could have, okay? When I say different types of beams that we could have, what this means is this. There are some beams that are parallel to themselves, like this. They are called parallel beams, right? Parallel beams. Some are convergent. When we say convergent, simply means they are pointing to a particular place. Okay? We call them convergent beams, because they are converging. Okay, you will learn more about this convergent beam when you are talking about what is it called now? Curved mirrors. That's lenses. When you're talking about lenses, not plane mirror now. In plane mirror, we talk about parallel beams of light. In plane mirror, that's both in reflection and in refraction, we talk about parallel beams of light. But when you come to curved mirrors, that you will learn maybe later, that's what is it called now? Convergent and divergent lenses. We talk about convergent beams of light and divergent beam of light. Divergent simply means they are leaving a particular point. So all you need to know here is to be able to draw these beams of light and know what they are called. That is what you are just required to know for now. So this one is convergent, then this one is what? Divergent. Okay? It simply means they are leaving a particular point. I hope we are clear about that. So we are done with definition, we are done with properties of light, we are done with terms related to light. Now, sources of light. Sources of light. I noticed from your notes that you were just going back and forth talking about artificial sources of light, talking about natural sources of light. You still come down here again, talk about natural light. You still come down here, talk about artificial. So I don't know. That's the reason why I'm asking you whether they dictated these notes to you. If I understand what you are trying to do here properly, you are just trying to you are trying to get. Sorry. If I understand what you are trying to do here properly, right? You are trying to differentiate between natural sources of light and artificial sources of light. And if that is the case, it is preferable you learn it by using a table like this instead of going back and forth. Use a table like this so that when you say number one, let's assume say natural sources of light are from nature, like the sun, the moon, and you give example. You come to this artificial, you say artificial sources of light are light that we could get from maybe electronic bulbs. You understand? Then you go to item number 2, you talk about it. You go to this artificial, you talk about it. Number 3, this is the best way you can compare items. Okay, just in case you are asked in exam. So what I expect you to do now, if this is the case that you are trying to differentiate between natural and artificial sources of light, draw a table like this. That same notes that you were given in class, position the natural sources items and the artificial sources items the way I've just done on this table. So I'm going back to our table of contents again. Going back to our table of contents, we are done with sources of light. Okay, now let's talk about laws of reflection, and we'll later talk about laws of refraction. Laws of reflection. Laws of reflection. When we are talking about laws of reflection, it's very important for you to know how to draw this diagram I'm about to draw now. This is a plane mirror. You see this part I'm coating here now is the coated part of the mirror. That's the back of the mirror, okay? Now, a line that you draw perpendicular to a plane surface like this line, perpendicular means there is angle 90 here, okay? A line that you draw like this is called the normal. It's called the what? The normal, okay? Now, the light ray that hits the mirror, how do you know the light ray that hits the mirror? You will know from the arrow here. You can see that the arrow is pointing to the mirror. Sorry. The arrow is pointing to the mirror. This ray is called the incident ray. Incident ray. I will just use letter I. Okay? Now, the ray that is leaving the mirror is called the reflected ray. I will use letter R. Okay? Now, the angle that is formed between the incident ray and the normal is called the angle of incidence. So I'm using theta I. Okay? While the angle that is formed between the normal and the reflected ray is called, you can just use theta R. That's the angle of reflection. Okay? It's very good you know how to draw this diagram. Sometimes it could be drawn the other way around. What I mean is this. It could be drawn like this. It shouldn't confuse you. The most important thing is for you to understand what you are doing. The line that's the ray that hits the mirror is the incident ray, and the ray that leaves the mirror is the reflected ray. From the arrows, you will know this angle is still your angle of what? Incidence. While this angle is your angle of what? Reflection. Okay? Now that you have known how to draw this diagram, let's see what the laws of reflection are talking about. Okay, from your notes, you said that reflection occurs when light travels from one. No, you made a mistake here. In fact, you made a mistake here. This is not reflection, this is refraction. Refraction, go and correct it in your notes so that you will not be confused. Now, this is reflection, but this is not. Okay, now we are talking about the laws of reflection. This is where we are right now. Okay, the first law says that the incident ray, the normal, and the incident ray, the normal, and you did not even know what you wrote here, so you are confusing yourself. All lie on the same plane. Now let me go and explain it. Let me say it properly the way it should be said, and thereafter I'll make you understand. You see, you are not copying your notes well. If you don't copy your notes well, you run into problem. You don't understand. You're not able to understand the notes when time comes. Okay, this is what. Excuse me. Sorry. This is what the laws of reflection is saying. Okay, it says that the incident ray, the normal, at least you know what is normal now, right? The incident ray, the normal, let's call it N, and the reflected ray all lie on the same plane. This is the plane we are talking about. This is the plane. They all lie on the same plane. Are they not lying on the same plane like this? Or if you want to understand what the law is saying, it's not that the incident ray is on this plane, then the normal is on another plane, then the reflected ray is on another plane. Do you understand? So just know that the first law of reflection states that the incident ray, the normal, and the reflected ray all lie on the same plane. Okay? Now, still going back to your notes. The reason why I can just teach without going back to your note, but the reason why I'm referring back to your notes is so that you can understand that the content of your notes is also equally important, so that you can understand that what I'm teaching is actually what you're supposed to know. Let me put it that way. All right. The second law states that the angle of incidence is equal to the angle of, I don't know why he didn't write it there, but what that law is saying is this. The angle of incidence, which is theta I, is equal to the angle of reflection, R. Okay? So the two laws of reflection, now let's take them again. The incidence ray, the normal, and the reflected ray all lie on the same plane. Then the second law, the angle of incidence is equal to the angle of reflection. So those are the laws of reflection. Okay? Now going back to your those are laws of reflection. Let's just leave it at that. Also know that we can have laws of refraction. The reason why I want to add this extra one now, this laws of refraction, is just in case, so that you will not start confusing it with reflection. Let's assume this is a glass prism, or this is water, as the case may be. Okay? Now, if light falls on this medium, no, this is air. This is air. If this is our incident ray, this line drawn perpendicular is called the normal, right? This place now is our angle of incidence. Okay? This place is our angle of incidence. This one here now is our refracted ray. So the first law of reflection also applies for refraction, in the sense that the angle, the incident ray, the normal, and the reflected ray all lie on the same plane. So I'll stop here. I don't want to go into the second law of refraction. It might be a little bit confusing for you, but just know that just the same way we have two laws for reflection, we have two laws for refraction. So I will end this video here. Thank you.